Canada, the Canadian Electrical Code, or AFCI, specifies testing requirements for new and old electrical installations. Firstly, continuity and insulation resistance tests must be performed for all conductors and cables in new installations. For existing installations, testing is required if the installation has been modified or repaired. Secondly, grounding electrodes must be tested to ensure they meet the specified impedance or resistance values. Thirdly, testing is required to verify correct polarity and phase rotation, especially for three-phase systems. Ground fault current measurement, or GFCI, protection systems must be tested to ensure they operate properly at the specified trip current. In the United States, the National Electrical Code, or NEC, specifies similar testing requirements for new and old electrical installations. Similar to CC requirements, continuity and insulation resistance tests are required for new installations and modifications to existing installations. Grounding systems must be tested to ensure they meet the specified resistance or impedance values. Arc fault circuit interrupters, or AFCIs, must be tested to verify proper operation and protection against arcing faults. Similar to CC requirements, ground fault circuit interrupters, or GFCIs, must be tested to ensure they trip at the specified current level. When testing electrical installations, several key tests are performed to ensure safety and compliance with the electrical codes. These tests include continuity testing, insulation resistance testing, ground resistance and impedance testing, polarity and phase rotation testing, ground fault circuit interrupter testing, and arc fault circuit interrupter testing. Continuity testing verifies that a complete and unbroken path exists for current to flow in a circuit. This test is performed with the power often uses a multimeter to check for a low resistance between 2 points in the circuit. A good continuous path will show a very low resistance, ideally close to 0 ohms. An open circuit, indicating a break in the path, will show infinite resistance. Continuity testing is essential for identifying wiring errors such as disconnected wires or broken conductors. Insulation resistance testing measures the effectiveness of the insulation surrounding conductors to prevent current leakage. This test, also known as a Megger test, applies a high direct current voltage, typically 500 volts or 1000 volts, between the conductor and ground or between conductors. The insulation resistance is then measured in megohms. A high insulation resistance indicates good insulation, while a low resistance suggests insulation breakdown or contamination. Minimum acceptable insulation resistance values are specified in electrical codes such as the Canadian Electrical Code, or SEC, and the National Electrical Code, or NEC, and depend on the voltage rating of the circuit. Ground resistance and impedance testing verifies the effectiveness of the grounding system in providing a low impedance path for fault current to return to the source. This test is critical for ensuring that protective devices, such as circuit breakers and fuses, will operate quickly to clear a fault and prevent electrical shock hazards. Ground resistance is measured using a ground resistance tester, which typically employs a 3-point full of potential method. This involves driving 2 ground rods into the earth at specific distances and injecting a test current between the grounding electrode under test and one of the ground rods. The voltage drop is measured between the grounding electrode and the other ground rod, and the ground resistance is calculated using Ohm's law. Ground impedance is measured using an impedance tester, which applies a low voltage alternating current between the grounding electrode and a nearby electrical point. The impedance is then calculated based on the measured voltage and current. Acceptable ground resistance and impedance values are specified in electrical codes and depend on the size and type of electrical system. Polarity and phase rotation testing ensures that electrical outlets and equipment are wired correctly with the hot, neutral, and ground wires connected to the proper terminals. Incorrect polarity can create shock hazards and damage equipment. Polarity testing is performed using a polarity tester, which plugs into the outlet and indicates whether the wiring is correct. Phase rotation testing is essential for three-phase systems to ensure that motors and other equipment operate in the correct direction. Phase rotation is typically tested using a phase rotation meter, which indicates the sequence of the 3 phases. Ground fault circuit interrupter, or GFCI testing verifies that GFCI devices are functioning properly and will trip quickly in the event of a ground fault. GFCI devices are designed to protect people from electrical shock by monitoring the current balance between the hot and neutral conductors. If a ground fault occurs, indicating that current is leaking to ground, the GFCI will trip and interrupt the circuit. GFCI testing is performed using a GFCI tester, which simulates a ground fault and measures the time it takes for the GFCI to trip. The tripping time must be within the limits specified in electrical codes. Arc fault circuit interrupter, or AFCI, testing verifies that AFCI devices are functioning properly and will trip quickly in the event of an arcing fault. AFCIs are designed to protect against fires caused by arcing faults, which can occur when damaged or deteriorated wiring creates a high resistance connection. AFCI testing is performed using an AFCI tester, which simulates an arcing fault and measures the time it takes for the AFCI to trip. The tripping time must be within the limits specified in electrical codes. The Canadian Electrical Code, or CIC, is the standard for electrical safety in Canada. It is developed and maintained by the Canadian Standards Association, or CSA. The CEC provides detailed requirements for electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect changes in technology and industry best practices. The CEC is divided into sections, each covering a specific aspect of electrical installations. Some key sections include Section 4 covering conductors, Section 12 covering wiring methods, Section 14 covering protection and control, Section 26 covering installation of electrical equipment, and Section 10 covering grounding and bonding. The National Electrical Code, or NEC, is the standard for electrical safety in the United States. It is developed and maintained by the National Fire Protection Association, or NFPA. The NEC provides detailed requirements for electrical installations, similar to the CEC. It is updated every 3 years to reflect changes in technology and industry best practices. The NEC is also divided into articles, each covering a specific aspect of electrical installations. Some key articles include Article 200 covering use and identification of grounded conductors, Article 210 covering branch circuits, Article 250 covering grounding and bonding, Article 300 covering wiring methods, and Article 400 covering flexible cords and cables. When performing electrical testing, it is essential to follow safety precautions to prevent electrical shock and other hazards. Always to energize circuits before testing, unless live testing is specifically required and proper procedures are followed. Use appropriate personal protective equipment, or PPE, such as insulated gloves, safety glasses, and insulated tools. Verify that testing equipment is in good working order and properly calibrated. Be aware of potential hazards in the work area, such as exposed conductors or energized equipment. Follow lockout/tagout procedures to ensure that circuits cannot be accidentally energized while testing is in progress. Electrical testing is a critical aspect of ensuring the safety and reliability of electrical installations. By performing these tests and following the requirements of the CEC and NEC, electrical professionals can help to prevent electrical shock hazards, fires, and equipment damage. Remember to always consult the latest editions of the Canadian Electrical Code and the National Electrical Code for the most up-to-date requirements and guidelines. In addition to the Canadian Electrical Code and the National Electrical Code, there are other resources available for learning about electrical testing and troubleshooting. Several websites offer articles, tutorials, and videos on electrical testing methods. The electrical equipment manufacturers often provide technical documentation and training materials on their products, including testing procedures. Trade associations and professional organizations offer courses and certifications in electrical testing and maintenance. It is recommended to pursue ongoing education and training to stay up to date on the latest testing techniques and safety practices. Furthermore, consider these specific points regarding electrical testing. Firstly, for continuity testing, ensure that the circuit is completely energized before performing the test. Use a multimeter set to the ohm setting and check for low resistance between the points being tested. Secondly, for insulation resistance testing, use a megometer, also known as a megger, to apply a high voltage direct current to the insulation. The test voltage should be appropriate for the voltage rating of the circuit. Record the insulation resistance value in megohms. Thirdly, for ground resistance testing, use a ground resistance tester that employs the fall of potential method. Follow the manufacturer's instructions for setting up the test and interpreting the results. Ensure that the ground rods are properly placed and that the test area is free of interference. Fourthly, for polarity testing, use a polarity tester or a multimeter to verify that the hot, neutral, and ground wires are connected to the correct terminals and outlets in equipment. Incorrect polarity can create shock hazards and damage equipment. Fifthly, for GFCI testing, use a GFCI tester to simulate a ground fault and measure the tripping time of the GFCI device. The tripping time should be within the limits specified in the electrical code. Test GFCI devices regularly to ensure they are functioning properly. Sixthly, for AFCI testing, use an AFCI tester to simulate an arcing fault and measure the tripping time of the AFCI device. The tripping time should be within the limits specified in the electrical code. Test AFCI devices regularly to ensure they are functioning properly. Seventhly, always document the results of electrical testing in a clear and organized manner. Include the date of the test, the equipment used, the test parameters, and the test results. Keep records of electrical testing for future reference and for compliance with regulatory requirements. Eighthly, when performing electrical testing, it is important to understand the limitations of the testing equipment and the testing methods. No test is perfect, and there is always a possibility of error. Use multiple testing methods to verify the results and to ensure accuracy. Ninthly, electrical testing should only be performed by qualified and experienced personnel who have the necessary training and knowledge. Electrical work can be dangerous, and it is important to take precautions to prevent electrical shock and other hazards. Tenthly, always follow the safety regulations and guidelines of the Canadian Electrical Code and the National Electrical Code when performing electrical testing. These codes provide detailed requirements for electrical installations and testing, and they are designed to protect people and property from electrical hazards. Remember that electrical testing is an essential part of maintaining a safe and reliable electrical system. By performing these tests regularly and following the proper procedures, you can help to prevent electrical accidents and ensure the safety of your home or business. Understanding the specific requirements of the Canadian Electrical Code and the National Electrical Code is crucial for anyone working with electrical systems in Canada and the United States, respectively. Both codes provide comprehensive guidelines for electrical installations, including specific requirements for testing new and existing systems. These tests, such as continuity, insulation resistance, ground impedance, and GFCI/AFCI functionality, are designed to identify potential hazards and ensure the safe operation of electrical equipment. Familiarizing oneself with these codes and the proper testing procedures is essential for maintaining electrical safety and compliance. Furthermore, various resources are available to assist in understanding and implementing these testing requirements. These resources include the official code books themselves, as well as training materials, online tutorials, and industry publications. By utilizing these resources and seeking guidance from experienced professionals, individuals can gain the knowledge and skills necessary to perform electrical testing safely and effectively. The Canadian Electrical Code and the National Electrical Code are not static documents. They are regularly updated to reflect changes in technology, industry best practices, and safety standards. Therefore, it is important to stay informed of the latest revisions and interpretations of these codes to ensure compliance with current regulations. Subscribing to industry publications, attending training seminars, and participating in professional organizations are all valuable ways to stay up to date on the latest developments in electrical safety and testing. In addition to the specific testing requirements outlined in the Canadian Electrical Code and the National Electrical Code, there are also general principles of electrical safety that should be followed at all times. These principles include always energizing circuits before working on them, using appropriate personal protective equipment, and verifying that testing equipment is in good working order. By adhering to these principles, individuals can minimize the risk of electrical shock and other hazards while performing electrical testing. It is also important to recognize that electrical testing is not a one-time event. It should be performed regularly as part of a comprehensive electrical maintenance program. Regular testing can help to identify potential problems before they become serious hazards, and it can ensure that electrical systems continue to operate safely and efficiently over time. The frequency of testing will depend on the type of electrical system, the operating environment, and the applicable regulatory requirements. In conclusion, electrical testing is a critical aspect of ensuring the safety and reliability of electrical installations in both Canada and the United States. By understanding the specific testing requirements of the Canadian Electrical Code and the National Electrical Code, following safe work practices, and staying informed of the latest developments in electrical safety, individuals can contribute to a safer and more efficient electrical environment. Remember to always consult with qualified electrical professionals for guidance and assistance with electrical testing and maintenance.